Hello guys, welcome back to where we stopped before on the video. We've looked at the overview of clustering in Juniper SRX device, and in this section we want to build the lab in EVE-NG so that we'll see how we can implement it. Then of course, if you have hardwares in your house or in the office or somewhere, you can just bring it out of shelf and you can also use it to configure this implementation and follow through with everything we want to do. Okay. Yeah, so for us, I've decided to use EFG so that if you're watching this video, you'll be able to follow through. And of course, like I always say, if you like this video, you want to subscribe, and you also want to share it with your colleagues in the office or your friends so that they too can watch it and benefit from it. Okay, so let's look at topologies. So at the basic level, we need just to XRS device. Now for the switches here, like I said before, we just want to use one switch for our implementation. As you can see, we're actually using one switch. In the real world, you definitely probably have, it could be still be one switch, but it should be redundant. Maybe with if it's Juniper, you use virtual chassis, or if it's Cisco, maybe Stackwise. If it's Arista, I think Arista does multi chassis pretty well. Axial, So it depends on the vendor. You can use any specific implementation for the redundancy for the switches. Okay, but for here we just need two switches, and we need one switch and two XRS. And for the servers, we can just use Tiny Linux, which is I already have it on my EVE-NG, right, for the servers. Okay, so let's go to Eve. So I'm just going to bring up the nodes. I have yeah, so this is the switch I'm using. I'm using 19.2 arrow revision 1.8. If you look at the topology, we need we've said it before, we need 5 ports, right? 5 physical ports. Okay, now there's also another port that we need called the FXP0. Okay, now you know that if you're familiar with Juniper, you know this is where you tie your management IP. Okay, but for Eve, they actually created an interface for FXP0. We can actually connect directly to this FXP0 it is not for Eve, maybe for virtual vSRX, because Eve is they are not the one that who wrote the code for the device. Okay, so you actually have this FXP0, so we actually need to sort of connect it as well, right? The FXP. And physical devices, you don't have this management, right? And like I explained before, the G0/0 is what takes up that role. Okay, so we actually have this, and then this is where we are going to assign the IP address and all of that. So what that means is we need 6 ports. That's where I'm trying to arrive at. Okay, so we need 6 ports on our device. Okay, so I'm just going to make it 8. It doesn't hurt. Okay, no, I need 2 devices, so I'm gonna pick 2. Yeah, so that's our device. Then we need a switch. I tested with a lot of switches. I think Arista performed better for EVE-NG, so I'm going to need a switch, and we can take, let's say, 18 ports. It's large. Okay, 18 ports is what we need from there. And then we can bring in our servers using Tiny Linux. You don't really need Tiny Linux because it needs 4 gigs to run. So it means I'm using 8 gig just to run the Tiny Linux for 2. You don't need that. You can just use a VPZ. But of course, I have a lot of memory, so I need to change this from VNC to Telnet so that we can console directly to it. So yeah. The next thing is, let's just do some renaming here, because if we console, it's going to show that name. So I'm just going to call it LA. Okay, so the name is already here from my previous testing, and we're going to call this LA secondary. Okay, cool. And then of course we can call this what do we call it? LA Arista switch. So I already have those names cached. Then this is our finance server. If you watch my ASA videos, you know the history of this server. This is the finance tool. Okay, so now we just need to do the connection. So let's just look at the connections again. So from 0 all the way to 4. So let's start from this secondary device. So from 0 all the way to 4. So 0 goes to 1, and then so 4 should also, something is messed up here. So this should actually be Ethernet 5. I'm just going to leave it for now. I don't know why I changed it, but of course the point I'm trying to make here is we have 5 physical connections here, right? Plus the FXP0. So 0 goes to 1, 1 goes to 2, 2 goes to 3, something like that. So let's do that. So comes here. So 0 on the firewall goes to 1. Cool. 1 goes to 2. Okay. 2 goes to 3. Okay. 3 should go to 4. Now you have to follow exactly how these connections are. Although we're still going to see it at the code level, what they actually map to, because what you see in the physical is going to be different from what you're seeing at the code level. Then 5, port 5. So we actually need. So let's see, 0. Yeah, so 5. We don't really need 5. We actually need up to 4. Okay. Yeah, but let's just connect 5. No, so I don't want to mess it up. So we have, from the topology, we have 0, 1 to 4 goes from 1. Let me just make this 4 so that we don't. This is Ethernet 4. Okay. Why this is Ethernet 5? Really? So that we don't mess it up. Okay, so 0 all the way to 5. So the next one starts from 6 all the way to 10. Okay, so let's do it that way. So here we know our 0 goes to 6, not FXP0. 0 goes to 6, and 1 goes to 7. Then 2 goes to 8, right? And 3 goes to 9. And then our 4, which is for the LAN connection, right, goes to port 10. Okay, so we have everything. So it's 0, so 5 port for now. Now we can just come back. So let's also connect our LAN connection. You know, this goes to port 11. So I don't want to mess it up with I don't want it to be different from what we have in our design. So this goes to 12. And then let's bring out the internet, which will be the network we're using in management. It's here. So put it here and then connect it to port 13. Okay, I believe that's what we have. Yeah, so it's port 13 here. Okay, so the only thing we need to add now is what is not captured there, which is the FXP0. So this is going to go to port, FXP0 will go to port 14 on the primary, or the one that will be the primary, and 15. Okay, so in the real world, you don't need that physical port, or that physical port does not really exist. Okay, now that we have that, what we just need to do is power up. Now, if you want to follow with this lab, you need to have a laptop that is running at least 16 gig of RAM, or 32 would be much better. Okay, but I think with 16 you should be able to you might be able to get this stuff running. Okay, yeah, because like I said, you don't really need this Linux servers that I'm using here. Okay, what? Yeah, so that's it. I'm going to pause the video a little bit, and let's console first. Let's be sure. Console, 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 console. Okay. So if you are running like if you don't have a lot of resources, you might want to start them gradually, slowly. Maybe allow one device to boot up first before you do the second, to have like a really stable network. Now for my own lab, I'm using EVE-NG in bare metal. Okay, so I have a laptop that has a lot of resources, and I'm not really using it for anything, so I just have EVE loaded at the OS level, right? It's not running on any hypervisor, it's directly on the hardware. And of course, EVE, I think EVE behind the scene, they use KVM. So there's actually virtualization for this. These are actually VMs, these devices you see. I think EVE uses KVM, but it's not already somewhere. Okay, so it's just one level of virtualization. Okay, but if you run it on top of VMware workstation, which is really not so good for labs, I have to be honest. Right, so the performance might be a little bit better if you're running the EVE on a bare metal laptop or server, if you have. Okay, which is what I'm doing in my case. Okay, see you when the device loads up. Okay, now the devices are up. Okay, primary, secondary, and I have my server. It looks like I did not console to the switch. So we also have the switch. So for the switch, I think the username is admin. So once you're logged in and as admin, you should be able to. Now I think zero touch provisioning is enabled by default. Okay, on Arista. So we just need to disable that by saying zero touch disable. So it's going to prompt a reload to the config part. So for the SRX, we just need to log in now. Let me make it wider. So I believe the password is root, and just a CLI. It takes us to the root CLI. We are in. For the finance, we don't need to do anything here for now. You can just leave it. Then of course the switch are still loading up. Okay, so let's go back to the topology. Now for the switch, basically better implementation might be to put them on the VLAN, right? So an access VLAN. So you can take this port and this port and put them on maybe VLAN 20 if you want, just to reduce the size of the broadcast domain. Okay, but we're not going to do it here. It's really not important. You can just choose the same broadcast domain across, but it's good to have it, because for example, if your internet traffic comes, it means though these IPs are not on the same subnet, they could actually, it's not, best practices will be to put all these ports that play the same functions in the same VLANs, okay, so that the internet and it breaks down the segments to limits the broadcast domain for each of the VLANs. Okay, but we really don't need that, so we just leave it. We are not configuring anything on the switch aside the maybe the port channels. Then the next thing is okay, so now the devices are up, right? We need to tell these two devices to join the cluster. Okay, now for clustering, there's something we call the cluster ID. Okay, and of course the node ID. Okay, now for the clustering, I think it's between 1 to 66. I don't know, we'll check it. 1 to 66 or so cluster IDs. I'm not sure, we'll have to check. But for the node can either be 0 or 1, because you can only have two devices in the node. We can only have two devices in a cluster. So the first device will be node 0, the second device will be 1. So here this will be node 0, and here will be node 1. Okay, now by default node 0 becomes primary, okay, while node 1 becomes the secondary. Okay, that's what, if you say you are node 0, this is node 1, the devices, this becomes primary and this becomes secondary. And then of course you can override that by creating your redundancy group, right? So we can create a redundancy group for, or we can change it from the redundancy group and say for redundancy group 0, which is the default, you should actually be secondary. Okay, so if you do that, that's how you override the default for the devices. So the first thing is we put them on the same cluster ID. Now cluster ID is unique. Okay, no, it's not unique. The two devices needs to be part of the same cluster. Okay, so here if we say the cluster ID is 10, this device also needs to be 10. Okay, but the node ID will be different. So here will be 0, node 0, and why this will be node 1. Okay, so the cluster ID needs to be the same for them to be part of a cluster. I think you can't have more than two devices in a cluster. It has to be just two devices. Okay, and then each of the devices have to have a unique ID, which is the node ID. Okay, so that being said, let's add these two devices to a cluster now. Okay, so I'm just going to bring up my CLI. So the command is very simple to add devices to a cluster. Okay, the command is set chassis set chassis cluster ID. Now we said we are using 10 in this case, but let's see the maximum values that we have. Oh, it's 0 to 255 actually. Okay, it's 0 to 255, not 66. I wasn't sure of that, that's why I said okay, it's 0 to 255, and so so we're just using 10 here. Okay, and we can say node, we have to give it a node ID. Okay, so let's say question mark, so you say node, you say node ID, and then it can be either be 0 or 1. Okay, so we're going to say 0 here, and then we need to reboot the device for it to be part of the same cluster. Okay, so I'm going to take the same config, take it to the secondary, and say you're the same cluster ID, but the node ID has to be different now. So you are node 1, while the primary is node 0. Okay, so we can then go ahead and do a reboot. Okay, so while the reboot is going on, once they come back up and they say, so what they are going to do is they are going to try to use their management interface that we talked about to send things like hellos, right? Trying to find the, so they're going to use this port that we've already configured. We didn't configure really, but we just connected them. Okay, so there's this connection that exists. They're going to use it to find each other. At the moment they find each other, they are going to automatically determine who should be primary and who should be secondary, and then they are now part of a cluster. What that means is, once they become a cluster, whatever changes you make here, whatever configuration changes you make here, automatically gets replicated to the secondary. It's not really replicated, but you know, because it's the same, it's a single control plane now, a single code per se, then whatever you do here ends up in the secondary device as well. Okay, And I don't think you can configure from the secondary. You have to do it from the primary. And whatever you configure on the secondary, I don't think it's get replicated to the primary. We can check that and see what happens. Okay. Yeah, so let's hold on for the devices to come back up, and then we continue the configuration. Okay, now the device is has rebooted their backup, so I'm just going to log back in, okay, to the two devices. They should see each other now. Okay, so on the primary, the command to know, okay, you can even see it, right? So you say I'm primary, I'm node 0, and here is saying I'm secondary, I'm node 1. This automatically tells you, yeah, that they are now in a cluster. But for us to actually say it, you need to say show chassis cluster status. Okay, so node 0 is primary and node 1 is secondary. Okay, yeah, so here that's what we're saying. And also you can set the cluster ID. Okay, cluster ID is 10. The status for failover, say failover count is 1. There's really not be failover, so maybe due to the reload or something. Now look at it, redundancy group 0. It's same thing I was saying before, that there's a default redundancy group 0, and your control links and the fabric links and everything related to management belongs to this redundancy group. So another command we can use is to say show chassis cluster interfaces. Okay, so this tells you, see the EM0, you say it's up, the control link is up, right? So they're able to synchronize their control plane, as you can see it from here. But the fabric link is still down because we have not yet implemented fabric links. Okay, there's a redundant pseudo interface. I'm not sure what this is. Now something else we need to talk about is, so if I say show interface status, let's see if we see anything here. Okay, the device is still loading up. Okay, the interfaces are not yet up. Okay, because you see all our interfaces are not here that we added, so we still need to give it a bit of time. But while that is baking, what we need to, now we are done with the control link. We know the control link is fine because it's up from our verification. We said the control link is up. Let's set up the fabric link. Okay, now for the fabric link, we can start from the primary. So I'm going to hit edit. Now before you do anything on this device, you need to set your password, right? So we need to say set root authentication password plain text. So just give it your password that you want. Okay, you can hit commit. So let's also do, I think when you do it on the primary, now it applies both on the primary and secondary. So we've already set we've already done that. Okay, something else we will need to do is to delete security, right? If I say show configuration, run show configuration pipe display set. So this security configuration that comes with the device, we don't really need them. Okay, we're just going to create as this screen policies and all of that. We just need to take them out now so that we are sure we are, remember the FXP0 interface I talked about as well. You can see it here, and you see it's actually mapped to the management, in this case for HTTP. So you can actually manage this device like from the GUI. I've never used that, I have to be honest. Okay, but you can definitely work well from the web UI, just like your Cisco ESDM. But we know we are the CLI guys. We like the CLI more. Okay, so I'm just going to delete that security. I don't need it. Okay, so commit check. So it's going to delete everything related to security. We just have a plain device. Show pipe, show configuration. Sorry, run show configuration pipe display set. Yeah. Did it not apply? Let's see. I said delete security. Oh, it's gone. I think maybe it needs a reload for it to actually be gone. So we'll have to by the end of this video we'll have to do a reload again before we move on to the next video, so everything is gone. Okay, but that shouldn't affect what we need to do here. So let's set up our fabric link. Now we know our fabric link are port 1 and 2, right? Yeah, but before we do that, let's just do this command again. Show interface stars. Let's see if our interface are up now. Yeah, it's up. It's up, but it's not yet fully up. Why do I say that? So I only have my port 1 to 5 here. Okay, I don't yet see the port from the other device. Okay, now what usually happens when you add devices to a cluster is, so when you add a device to a cluster, the first device, so this is our first SRX, this is the second, right? This box have ports 0 to, let's say in this case is 0 to 5, right? 0 to 5, which makes it 6 ports. So this device to have 0 to 5. Now the question is, remember they both share the same control plane, right? So whatever you're doing here is actually applying to the two devices. What makes this port unique from this? How do you know if it's on the second port or on the first port? Now what Juniper does is there's something called, there's the offset that comes in. Okay, so why for the first device the ports are going to be GE, it's going to be 0/0/0 all the way down to 5. For the second device, the port, there's going to be offset. Now I think it depends on the hardware, right? But for the vSRX, which is what we are using in this case, is going to have an offset of 7. So what you actually now have is 7/0/0 to 5. Okay, so this 7 tells you, oh, these are the ports on the second device, right? That's a part of the cluster. So there's always that offset number that comes in. I think I've seen 5 before for some hardwares. There could be different values for some other hardwares, I'm not sure. Okay, but that's what we need to see here. So that's why I'm saying they've not yet showed up here. Okay, because for now we're only seeing one device. So we're just going to, let's try it again, see what happens. It's still not here. So we need to say, let's say run show chassis cluster. Let's be sure that they are still in a cluster. They should be. So this is virtual environment, so of course the performance is always different. Okay, it's a little bit slow, but when you wait, those spots are going to show up. Okay, so I'm going to say show interface stars again. Let's just try for the last time. It's still not there. It's still not there. So what I'm just going to do now is I'm going to do a reload of the device again, just to clear out those security informations and all, right? And then when it comes back up and the port has appeared, then we'll move on to the next part where we set up the fabric link, and we'll set up the fabric link, set up the LAN and WAN link, just run through the remaining part of the implementation. Okay, so I'm just going to say request system reboot. Okay, I think should only apply to one device, so I'm just going to run it here. So there's a reboot there. Let's also check here. It looks like, yeah, so this automatically, so you see the failover has automatically happened now. Because there's a reboot here, the secondary automatically assumes the primary role. Okay, so we can say show configuration pipe display set. You see the security is actually gone now. Yeah, but I'm just going to do a reboot as well. Say request system reboot. So once it's back up, then we continue from where we stop. Okay, so it's going to come back up. I'm going to be sure that the ports from both sides are merged now before we continue the next video. Okay, thank you and see you in the next video. Like I always say, if you like this video, you want to subscribe and share, so that when I make new videos like this, you'll get the notifications and benefit from it. Okay, thank you. Bye.